Alrighty, we are looking at congruent triangles in this set of notes, which actually isn't too bad. This is actually probably something you've seen before, so really what these notes are going to do is build on something you've previously seen and add a few more details. By the end of these notes, we're going to be solving equations with congruent sides and angles, but we're going to start at the very basics. So, congruent triangles. Congruent triangles are triangles with the same sides and angles. This also means that all corresponding parts, all corresponding sides and angles, are congruent. And we can see this in the second section. So, for example, we see that angle A and angle D both have one arc. Those one arcs each mean that angle 1 and angle D are congruent to each other. Whatever measure they have, it's the same for both triangles. The same with B and E, and then C and F. We can also say the same for segments AB and ED, as well as any other pair of corresponding segments. If we look at the name of these triangles, the angles are actually lined up in order with their corresponding angles. So A and D are in the first position, B and E are in the second position, and C and F are in the third position. A and D are corresponding, B and E are corresponding, C and F are corresponding. So we can use this information to help us with this idea called CPCTC. Now, that's a mouthful. I'm going to tell you what this acronym stands for, but I really prefer to use the intuition. Basically, this stands for corresponding parts of congruent triangles are congruent. Two parts in the same position of two congruent triangles are the same. We can use that to make a bunch of congruency statements about triangles JKL and PQR, even if we can't see the triangles themselves. Since angle J and angle P are in the same position, we can say that angle J is congruent to angle P. We can say the same thing about K and Q. Angle K is congruent to angle Q. And finally, the same about angle L and angle R. Angle L is congruent to angle R because they're in the same position on my congruency statement. I'll say the same thing about sides. Segment JK is congruent to segment PQ. Segment KL is congruent to QR. Segment LJ is congruent to RP. I can also make a new statement about the entire triangle. Instead of doing JKL is congruent to PQR, I can start with a different letter. KLJ is congruent to QRP. Triangle KLJ is congruent to triangle QRP. This works because all three of my corresponding angles are still in the same relative position. So I want you to take a second to pause and fill out a similar table for triangles YXW and triangle EFG. You can still fill everything in even without being able to see the picture of the triangle, just by lining up which angles and sides are corresponding to each other. Pause, and then we'll continue with question 3. Okay, so we can just briefly say that angle W is congruent to angle E, angle X is congruent to angle F, and angle Y is congruent to angle G. Similarly, segment WX is congruent to segment EF, segment XY to FG, and then YW with GE. Okay? And triangle x, y, w is congruent to f, g, e. Okay, and question 3 is when we really start to start solving problems with this method. We know that triangle KPM is congruent to AYC. Now, it's very tempting to just use your eye to solve all these congruency questions you see on your right. And that's what I did when I was in school. But I promise you, you are much more likely to get the correct answer if you do a little bit of notation to keep track of where you are. I recommend you use arcs to show which angles are corresponding to each other. For example, angle K is corresponding to angle A. I'm going to put one arc in both of these triangles, like so. Angle P is corresponding to angle Y, so I'm going to do 2 arcs for both of those triangles. And then angle M and angle C are corresponding, so I'm going to put 3 arcs in both of those angles. By doing this, I'll be able to keep track of the orientation between the 2 triangles. So it's easy for me to tell now that KM is corresponding to CA. And as a heads up, the order of the C and the A does not matter. AC is also a valid answer. Next, congruent to CY is PM. Lastly, congruent to PK is going to be YA. Pause and see if you can fill out the rest of these. Okay, so congruent to angle Y is angle P. Congruent to angle K is going to be angle A. Then congruent to angle A, CY, that's 1, 3, 2. 1, 3, 2 is going to be KMP. Angle KMP. Finally, triangle MPK, 3, 2, 1 is going to be congruent to triangle CYA, 3, 2, 1. Lastly, YAC, 2, 1, 3 is going to be congruent to 2, 1, 3, 2, 1, 3, PKM. All right, fill this in, then we're going to go to the back. Okay, for these, I'm going to solve questions 4 and 6, and then leave questions 5 and 7 for you. For question 4, I want to make sure I fill in all of my missing information first, and then transcribe it to the table, starting with my arcs like I did in the last question. Angle S and angle B are both going to be 1 arc. Angle T and angle F are both going to be 2 arcs. And then angle W and angle N are both going to be 3 arcs. Okay, now that I've done that, it's pretty easy for me to tell that WS and BN are corresponding, so this measure here is going to be 9 centimeters. WT and FN correspond, so this is going to be 14 centimeters. And BF and TS correspond, so this is going to be 17 centimeters. Awesome. N and W correspond. This will be 82. And S and B correspond, so this is 67. Neither of my angles for arc 2 have a measurement. So to find the measure of T and F, I have to take my given measurements and subtract them from 180. So I do 180 minus 82 minus 67. And that's going to be, I believe, 31 degrees. Once I have all that, I can fill in my answers. BN was 9, TW was 14, and BF was 17. Angle W was 82, angle B was 67, and angle F was 31. Okay, I'll give you a moment to solve question 5, and then I'm going to move on to question 6. Okay, moving down to question 6, I'm going to use congruency rules to solve equations. First, I'm going to use my arcs just like before. Angle U corresponds to T, so they each get one arc. V corresponds to S, so they each get two arcs. W corresponds to R, so they each get three arcs. Okay? Now that I've done that, I can use this to orient myself and make sure I line up the right equations. So, TS is between 1 and 2, UV is between 1 and 2, so I get 12x minus 7 equals 53. This equation will allow me to solve for x, which I need to do to answer this question. I'm going to add 7 to both sides, 12x equals 60, divide by 12, x equals 5. Okay, that's one answer gotten. Next, I want to keep on going. So I know that TR is 1 and 3. U is 1 and 3. So I can say that 3z plus 14 equals 50. Is that correct? Yes, it is. I'm going to subtract 14 from both sides and find that 3z equals 36. Divide by 3. Z equals 12. Lastly, VW is 2, 3. SR is 2, 3. So I can find that 5y minus 33 equals 57. Okay? So I add 33 to both sides. And I have 5y equals 90. Okay? Divide both sides by 5. And y equals 18. This gives me all three of my answers to this question. The most important trick I can give you is to make sure you put arcs on all of the angles, on all of your corresponding angles. This will make it easier for you to orient to the question and make sure you get the right answer. I'm going to leave questions 5 and question 7 for you to solve on your own. As always, let me know if you have any questions, and I look forward to seeing you in the next class. Have a great day. Bye-bye.